On 8-4, we're going to multiply and divide rational expressions, which means we always want to reduce before we multiply or divide, okay? So we're gonna really look at canceling things out, factoring things out and canceling things. So, if you have AC over BC, you can cancel out the C's and you get A over B. If I have 15 over 65, I can reduce that down. I can take a 5 out of both, right? And I get 3 over 13. Same happens when I'm using rational expressions. If the same rational piece is there, I can cancel it out, okay? So if I have 4 parentheses x plus 3 over x minus 5x plus 3, I can cancel the x plus 3 out, and I get 4 over x minus 5. And that's as far as I'm going to go. So on everything we're doing tonight, you're simplifying. There's not necessarily a solution, okay? So we're going to just simplify things down. So we have this. We have x squared minus 2x minus 15, okay? X squared minus 2x minus 15 over x squared minus 9. What do you think we need to do to simplify this? Boil it, factor it out, yes. It's been boiled, we need to factor. Up top, what multiplies to give me negative 15, adds to give me negative 2? 5 and 3. So I'm going to say x, I'm going to have a 5, I'm going to have a 3. Which one's positive?
Negative 5.
Negative 5, positive 3. What do I have going on down here? X squared minus 9.
X.
Plus 3x minus 3.
Good. Yes, x plus 3, x minus 3. What is that called specifically? It's a special type.
Difference of 2 squares.
Difference of squares. Good. Now, what can I do from there?
X plus 3 is
Perfect. And I'm left with this. X minus 5 over x minus 3. Listen to me very closely. Do not try to cancel the x's out here. It is part of a function. X minus 3 is a whole thing I have to do. I can't cancel my x's out, okay? That's the biggest mistake people make is they try to cancel the x's out on all this stuff. It's a whole thing, okay? It was in those parentheses together. I can't get rid of it individually, okay? I have to get rid of the whole. So this is as far as I can go. X minus 5 over x minus 3, okay? Simplifying. So, then we get to like more complicated stuff where it has x, y's, z's, numbers, and we're just gonna reduce everything down. I always prefer to start with the numbers, like let me reduce the numbers, then let me go to the x's, then let me go to the y's. And remember, when you have powers, like see how this is 5x squared, 2xy squared times 6xy cubed, 10y, okay? They multiplied it all together. I don't necessarily do that. I'll just look here and see what can I cancel out. Oh, a 5 and a 10, that becomes a 2. Oh, a 6 and a 2, that becomes a 3. Okay? I'll look up top and I'll say, I have 3 total x's, on bottom I have 1. Cancel the bottom out, I'm only left with 2. Okay? I have 3 y's, I have 3 y's, they'll cancel completely. And that's how I usually get to the answer, because my theory is if you don't need to multiply it together to cancel out, why do more work? Okay? So, when you I don't know why I did that. So, then I get problems like this, where it has it multiplied together. So I have 8x cubed y over 2xy squared times 7x to the 4th y cubed over 4y. Now, can anything number-wise be canceled?
8
What?
and 4.
Okay, what does 8 become when 4 goes into it?
2.
Okay, can any more numbers be canceled?
The X one.
Look, what do I have here? 2 and 2. So that 8 cancels out completely. I'm just left with a 7 up top, okay? I usually start to bring that down so that I know what's going on, okay? How many x's do I have up top?
7.
Okay, how many on bottom?
1.
So this is what I would do. I would say, cross that out, change this to a 2. So then x squared and x to the 4th gives me what? X is 6, because when I multiply, I add. How many y's do I have up top? 4, and on bottom I have?
3.
So I say, okay, cancel, 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 and you're left with, okay.
Just put that over 1.
So there's nothing underneath, and I can leave it like this.
Is this all we're doing?
This Peter
Or is
is
it
a
difficult?
Well, we're gonna do more, so it's a lot of it's a lot of it's a lot of it's a lot of. Each one is different, so you just gotta walk through it. Okay, but do you see what I did? I started with numbers, then I focused on one variable, then focused on the next. You okay, Jackie? Is it confusing? Okay. Okay, so then we get a little bit more complicated ones, like systems of functions, okay? So here I have 3x, oh, I swear I grabbed red, going crazy. 3x minus 3x squared, okay, over x squared plus 4x minus 5 times x squared plus x minus 20 over 3x, okay? Before we do this, what do you think I probably need to do to each individual piece? Factor as much as I can before I even start anything else. So focus on this top. Can something factor out here?
3x.
Okay, when I factor out a 3x, that means I get 1 minus x, correct? Okay, because 3x times 1 is 3x. Don't forget that 1 goes in. Let's factor the bottom. What multiplies to give me negative 5 adds to give me 4.
1 and 5.
Positive 5 and negative 1.
Positive 5.
Positive 5, negative 1. Okay. Over here, I have to factor. What multiplies to give me
4 and
negative
5.
20 and adds to give me positive 1?
Positive 5.
Positive 4.
Positive 5, negative 4, and this bottom part cannot factor, correct? Okay, so then I just start by saying, let's see what we can cancel. 3x, can I cancel that out someplace? Yes, because there's 1 here, there's 1 here. 1 minus x.
Yes.
No,
No.
because it's under, it's not cross.
No, not y.
It's
This
because it's
says
flipped.
1 minus x. This says
X minus 1.
is not the same thing, okay? We'll talk about that in a second. X plus 5.
Yes.
Okay, so we get this, yes? Now, let's talk about this 1 minus x. Is there a way that I could get it to say x minus 1? Take out what? Take out a negative 1? Yeah, I can take out a negative 1, okay? So if I factor this to say negative 1, that changes this to positive x minus 1, yes? Do you see what I did there? I took out a negative, that flips the sign, so I put it over there just so that it looks like the same order, okay? So this becomes the combination of these two things, which means now I can cancel it out. Now, on bottom, do I have anything? Up top, I have negative 1, correct? Times, what do you think I'm gonna do with that?
Distribute.
So negative x, and there's my solution, my simplified version. Okay, so if for some reason it's switched in that order, you have to pull negative out of one of them, or positive, whatever it is, that you can cancel it, okay? So you can cancel it, just don't forget you have to pull that out. Okay, what happens when it's like this?
It's over 1.
It's over 1. It's over 1. X plus 2 over x cubed minus 27 times x squared plus 3x plus 9 over 1. Now I'm going to test your memory. Okay, up top stays the same, x plus 2, correct? What is this called? What's x cubed minus 27?
Difference of cubes.
Difference of cubes, and there's a pattern for that, so can you tell me what that pattern
Oh,
is?
I got it.
Okay,
It's you just put the x inside, and you put like
what's the
put
cube root of 27?
3.
3. Okay, and then what goes here? It's this squared,
Squared.
and then it's plus these two multiplied together,
Or.
It's not.
I forget that.
and then it's plus this squared.
Wait, wouldn't that be x squared minus 3x? Since it's a negative 3?
No, because watch, x times x squared gives me x cubed. X times 3x gives me 3x squared. X times 9 gives me 9x. Negative 3 times x squared gives me negative 3x squared, so they cancel. Negative 3 times 3x gives me negative 9x, so they cancel. And negative 3 times 9 gives me negative 27. This negative makes it so that it's positive. If this, that's just you just have to have that memorized. That's why I told you guys in that chapter where we did all the factoring, you don't want to forget this. This is important.
Yeah, but when you said that the second thing is just those two multiplied, it's a negative.
You don't take the sign with it. You just know that this number and this number are multiplied together. Okay. So then I have x squared plus 3x plus 9 here, and I have it all over 1. What cancels out? Okay, that's why I didn't factor this first, or try to factor it, not that it would work, but I didn't try to factor it because I realized this was a difference of cubes, so I went ahead with that. If I realize something's a difference of cubes or a difference of squares, I'm gonna work with that first, because then I might not have to factor something that's bigger. Does that make sense? Okay, so then up top I get x plus 2, and on bottom I get, boom, don't cancel those x's. Okay. So then we get into dividing rational expressions. Now listen, dividing is super simple, which is why I'm teaching it in the same lesson. When we multiply, we just factor and cancel out. When we divide, what's the only other step we have to add in?
Multiply.
You do what? You need to flip it. You need to flip the second one and then you can do the same stuff, yes? Okay. So, here we go. You have 7x, okay, over 2x minus 10. I'm gonna say times, which means I am flipping, correct? X squared minus 11x plus 30 over x squared minus 6x. So that's why I'm teaching it all in one thing, because dividing, you just flip, right? I mean, there's nothing to it. This right here stays the same, correct? 7x? What factors out here? 2. So you get x minus 5, correct? What factors here? What multiplies to give me 30, adds to give me negative 11?
Negative 6,
Five.
negative 5.
Negative 6, negative 5. What happens here? What factors out there?
X.
X, so you get x minus 6. What can I cancel?
X minus 6, X minus 5.
Beautiful. And what else?
The X on the 7.
The x on the 7. Carissa, why can I cancel the x on the 7 there, but I can't cancel it here?
Because it's not part of a thing that's adding or subtracting.
Right. If it's adding or subtracting, I can't cancel. If it's multiplying, I can. So my answer becomes,
Because it's just like dividing it.
correct.
And we can keep that as a fraction.
And you can keep it as a fraction, or you can give me a decimal answer, I don't care, or a mixed number, whatever floats your boat. Okay? So, math facts are very important in what we're doing today. Last one, I tried to give you like several different
Can you
examples.
just put 1 over that?
You would put 1 over it, yes, Kaden, very good. So 6x squared plus x minus 15 over 4x squared. And when we flip to multiply, Caden's saying just throw 1 up there, and you get 3x squared. If I could write, that would be great. Now, let's factor. How do I factor here? Ooh, that leading coefficient is not a 1 anymore, correct?
That's gonna take way too long.
Okay, so this is the ones where we have to think, because we have to think factors of 6, factors of 15, get me 1 in the middle, you know what I'm saying? Okay, so 6 is 1, 6, 2, 3, yes? 15 is 1, 15, 3, 5? Okay. If I multiply 1 and 3 together and 6 and 5 together, can I get to 1? No, that's too big. If I multiply 5 and 1 together and 6 and 3 together, can I get to 1? No, so we know that won't work. And I know 1 and 15 and 1 and 6 won't work, that's common sense. Okay. Okay. 3 and 2,
6,
5 and 3,
8,
10.
15. Okay, 5 and 2, 10, 3 and 3,
9.
ah. So I'm gonna have to do 2x, yes? I'm gonna have to do 3x. I need this to have a 5 with it. I need this to, well, it's not a pop, I don't know what the sign's here yet. I need this to have a 3. So yes, this is positive because that's 10, and this would be 9, because that's positive and negative, okay? On bottom, I have 4x squared. On top, I have 1, makes my life easier. Can I factor anything out from here?
X.
X.
I got X.
Okay, now, what can I cancel?
3x plus 5.
3x plus 5, okay? So then you get 2x minus 3 on top. On bottom, you get 4x cubed. And that's as far as I can go. Coolio,
This is, I love this lesson. This is
Okay.
so nice.
that's what you're working on tonight.
This is-